Okay, so yesterday we have ended the class over here. We have completed 3 questions. Now we are going to move towards question number 4. Yeah, okay, just a minute, please. Okay, yeah, calcium nitrate, CaNO3 twice, reacts with ammonia, carbon dioxide, and water to form a mixture of ammonium nitrate and calcium carbonate. Okay, and here we have the chemical equation. Explain why ammonia is described as a Prost-Glory base in this reaction. Okay. So if you see, yes, can anyone recall? Very good, Hassan, because it's a proton acceptor. It accepts a proton over here because if you see, there is a 3 hydrogens with it and it will become NH4 ammonium ion, right? So it accepts a proton. So it is because it accepts a proton. Okay. Now, product mixture can be added to the soil. Okay. State 2 reasons why this mixture of products is added to the soil, to some soil. Okay. So if we talk about, see, it's a mixture of these two, right? They are talking about this mixture over here. So one is ammonium nitrate and one is calcium carbonate. So why we add this? Because, yeah, very good, Hassan, very good, Hadi. Uh, Ammonium nitrate act as a fertilizer. So this mixture act as a fertilizer. Then calcium carbonate is present in the mixture, which actually neutralizes the acidic soil and increases the pH of the soil. Yeah. So this fertilizer thing is due to, remember, from the mixture, it's due to ammonium nitrate in the mixture. And the other thing that neutralizes the acidic soil is because of calcium carbonate present in it. Is this clear? It is stuck. Okay. Now, complete the table to name, shape, and give the bond angles of each species. Okay. Carbon dioxide. So if you work on a carbon dioxide, see, if we look at the central atom, 2 bond pairs around it and 0 lone pair around it. That makes a shape linear. And when the shape is linear, then the bond angle is 180 degrees. So this bond angle is going to be 180 degrees. Okay. Then ammonia. If you work on ammonia, there is a lone pair on nitrogen and 3 hydrogens as it's of group 15 or group 3. So it has 3 bond pair and 1 lone pair, which makes the shape trigonal pyramidal. And in this case, the bond angle is 107 degrees. So you have to remember these. Yes, Hassan, very good. Not 117 and Shara, yes, Fatma 107. Yes, and Shara. Okay, for water, it's two bond pair and two lone pairs, right? So two bond pair and two lone pair around oxygen atom, the central atom. Yes, non-linear or bent or V shape. Yeah. So you can write non-linear, you can write angular, you can write bent, you can write uh, V shape. And the bond angle is, yes, Athena, 104.5. Good. So you have to remember these. No, it's not 109 and Shara, it's 104.5. Okay. Now, let's move to the question number 5. Below is a list of species which can react with organic compounds. From the list, identify species which can react with ethane. Okay. And if you recall, ethane is an alkane, and with alkane, either oxygen would undergo a reaction. Yes, Banin, very good, chlorine, because you know, combustion. Otherwise, halogens would react. So for with ethane, only chlorine would be the answer. No, HCl. How HCl would react with alkane? If you recall the reactions of alkane would undergo three reactions. Cracking. For cracking, it doesn't need any reagent. It does not react with anything. Instead, it would do substitution, right? In substitution, Jaslan, if you recall, HCl is formed. It reacts with the halogens, right? So it would undergo cracking. It would undergo substitution, and in substitution, it reacts with the halogen, not HCl. And combustion. So these three reactions alkane would undergo. And here only in combustion it reacts with the oxygen. So there is no oxygen. It in substitution reacts with the halogen. Okay. From the list, identify two species which can attack the pi bond in ethene. Okay, very good. So recall pi bond in ethene, a double bond. So yes, yes, Banin, very good. If you recall the reactions of alkene, yes, Hassan, very good. So these two are the things, HCl and H2O, the halogens being added, the halogen hydrogen halides being added in alkene, and then water being added in alkene and hydrogen being added in alkene. So HCl and water would be the answer. Yes, is this clear to all of you? Okay. Okay, am I audible now? Okay. So HCl and water would react. Now, from the list, identify species which can be used to distinguish between the solutions of propanoic acid and propanol. Describe any relevant observation. Okay, propanoic acid is a carboxylic acid and propanol is an OH and alcohol. So a reagent out of these which we can add, and it is used to distinguish among these two, the propanoic acid and the propanol, the carboxylic acid and the alcohol. Just give me a minute, please, everyone. Yes, am I audible now? Yeah. So can any one of you tell me any species which is used to distinguish between these two, propanoic acid and propanol? Yes, very good. How bromine test? Shrey, very good. Ishal, very good. And Shra, cyanide. When you react the cyanide with the alcohol or a carboxylic acid, think, please, think. Yes, most of them would give me a correct answer. See, it's a carbonate because if you recall, a metal carbonate reacts with an acid. So a carbonate ion. So first I'll write the answer that carbonate and then describe any relevant observation. So with propanoic acid, we will see effervescence, and with propane one, all the effervescence would not be seen. I don't know if the internet is actually doing a problem. Okay. So carbonate and it shows effervescence with propanoic acid and show no change in propane one all. Till here, is this clear to all of you? Now, chlorine, it's an atom, right? Can be made from chlorine molecule. Both are gases. Yes, very good. Hadi, describe the conditions required for this process. So if we have to break the atoms from the molecule, yes, very good, Hassan and Hadi. We need a UV light. Name this process. Yes. What is this process called? Who will name it? No. The whole reaction is free radical substitution. They are asking about this process. When chlorine molecule turns into this. Hmm. Yes. So it's a bond breaking. And which kind of bond breaking? A homolytic breaking. Okay. It's a homolytic breaking, or you can call it homolytic fission as well. Next, name an organic functional group which reacts with the nucleophile in addition reaction. Yes, can anyone tell me the name? Name an organic functional group which reacts with the nucleophile in an addition reaction. So, Yes, very good. Ishel CN is a nucleophile if it would have a positive charge. Yes. So it's an aldehyde, right? Or a carbonyl, or you can write ketone. All are the functional groups, right? Which can undergo nucleophilic addition reaction. So you can write aldehyde, or you can write ketone, or you can write carbonyl, anyone. Okay. Name an organic functional group which tends to react with a nucleophile in an SN1 substitution mechanism. Yes, which organic functional group will undergo SN1 substitution mechanism? Halogen is not the functional group. Halogen is itself an, and see, it's specify SN1. Yeah, halogenoalkane, but halogenoalkane will not get you the full mark. It's 1 mark. So it's SN1. So which halogenoalkane would undergo SN1 substitution? Tertiary. Yes, very good. Tertiary. So you have to mention, because see, they have mentioned over here that SN1 substitution. So you have to mention the complete name by writing the tertiary in the prefix, because they have asked you about specifically about SN1. So tertiary halogenoalkane. Secondary would undergo any one, right? It can undergo primary, or it can undergo SN1 or SN2, both. Yes, but see, if they have specified the mechanism, they didn't ask you the nucleophilic substitution only. For example, if the examiner asks you, name the organic functional group which tends to react a nucleophile by nucleophilic substitution mechanism, because there are two types of nucleophilic substitution, SN1 and SN2. So we just write halogenoalkane, then halogenoalkane would be considered as a correct answer. But see, they have specified the mechanism specifically, that it's a not just a nucleophilic substitution, it's a SN1 nucleophilic substitution. So if so yes, what I was telling you, that see, they have specified the mechanism. They don't just ask you the nucleophilic substitution. They have specified it SN1 substitution. So for SN1, we know that it's a tertiary halogenoalkane, not just a halogenoalkane. So that's why you have to write tertiary halogenoalkane. Is this clear now? Okay. Now D part. Butanene reacts with a steam in the presence of a concentrated phosphoric acid to form two isomers of a molecular formula C4H10O. Okay, butanene. Each reaction occurs via different intermediate ion. Draw the structure of both intermediate ions. So C. Okay. So see, instead of the whole mechanism, they ask you to draw the intermediate ion. So if you recall the butene, let me show you. Isn't it? It's like this. CH3, CH2, CH, double bond CH2. So it's a butanene, right? And it would react with the hydrogen first, as we have seen in when we are reacting with HBr, right? So the attack would take in place from here. So if the attack would taking place from here, so there are two possibilities. One is this one, that CH3, CH2, CH, single bond, CH2, a hydrogen gets bonded to this carbon from the water. Oh no, it's again stuck. Am I audible now? The internet. Okay. So if the attack would take place from this bond, so there would be two possibilities. One is the hydrogen gets bonded to this carbon and making this carbon a positive. So this would be one intermediate, right? And the second one would be that CH3, CH2, these two remain same. This is CH and this is CH2. After the attack, the hydrogen gets bonded from the water. The hydrogen gets bonded to this carbon, and this carbon becomes a positive. So would be the another intermediate. Is this understandable? So obviously, there is a double bond. So attack would take place from here. So when the attack takes place from here to the hydrogen of the water, so either this carbon gets bonded with the hydrogen, making this carbon a positive like this, or on the other side, this carbon gets bonded with the hydrogen and this carbon becomes positive. So this is the other possibility. And my screen is again stuck. I don't know. Okay, tell me till here, is this clear? Okay. Now, what they are saying, circle the more stable intermediate ion drawn in D1. Explain your answer. Okay. Circle more stable in D1 and explain your answer. So which one is the more stable one? Yes, you guys, who will tell me, the right one or the left one? Ishal said left, Hadi said right. Any other? Hassan said left. Okay. Shrey said left. Ali Asgar said left. Okay. So left is the more stable one. See, because it's a secondary carbocation. If you see, the carbon which got a positive charge has one hydrogen only, and the carbon which gets the positive charge has two hydrogen only. So it's a primary carbocation, and it's a secondary carbocation. And why my screen is not working? Yeah, the left one. So the left one is more stable. So I'll make a circle on this one. See, it is more stable because see, this is the carbon And this carbon is bonded to one hydrogen and two alkyl chains, making it a secondary carbon, a secondary carbocation. And this one is a primary carbocation because the carbon which is having a positive charge, a carbocation, is bonded to two hydrogens. So primary is less stable. Yeah. So explain your answer. The one which I have circled, it has two alkyl groups bonded to carbocation, hence has more inductive effect and a lower charge density. Yeah, more electron donating, very good, Ishal. Alkyl groups. More alkyl groups, so more electron donating effect, which stabilizes it, which makes it's stable than the other one because the other one is a primary. Till here, is this clear? Okay. Now we have a question number 6. Here we go. 2-methyl butanene reacts with acidified manganate 7 ions. Okay. Under specific conditions to produce two organic compounds X and Y. So if you recall 2-methyl butanene, so butanene, if I draw the skeletal formula, butanene and 2-methyl, so it would be like this. Okay. So on breaking of this, we got a carbon dioxide. Okay, see, interesting. Here you are getting a carbon dioxide. And here it's a ketone. So see, if you in problems, yes. So it's the question. It's the same question which I have told you guys. If you recall, now it's working. See, if I break it from here, what's supposed to be make? The carbon which is on the left turns into carbon dioxide and the carbon which is on the right turns into ketone. So see, this is the ketone over here. And this carbon dioxide is over here, and here they have made something else. So if you recall, that's what I have told you, that if this is the case, then do remember that here you will get a methanoic acid first, and that methanoic acid turns into a carbon dioxide. Is this understandable? Is this recallable? That's what I have discussed with all of you. See, that's what they are saying. X immediately reacts with acidified manganate to form carbon dioxide and water. So that X is this thing. So on breaking, the one carbon basically turns into methanoic acid and then forms a carbon dioxide. Okay. Draw the skeletal formula of 2-methyl butanene. Okay, I just did it above. So butanene. So but means 4 carbon atom, made up 4 carbon atom. 1-ene means double bond on a first carbon, and 2-methyl. So a carbon chain, 1 carbon on the second carbon. So that would be the skeletal formula. Okay. Now, state the specific conditions. Okay. State the specific conditions required for acidified manganate ions to react with 2-methyl butanene in this way. Yes, what are the hot and concentrated? Very good. Hot and concentrated. Acidified, it's already there. Acidified has been mentioned. So the two conditions that we need, hot and concentrated. If it's cold and dilute, then we got the diol, right? Hot and concentrated. Very good, Ishal. Okay. Name the type of a reaction occurring to the functional group in 2-methyl butanene in reaction in B1. Okay. Yeah, in the reaction B1, which what happens to this? It's oxidation. right? It's oxidation. Okay, yeah, very good. Now, draw the structure of the formula of X. Someone left the class. Yes, draw the structural formula of X. So we have already identified X. So I can easily draw it. It's HCO2H. It's a methanoic acid, right? Now, describe a chemical test, the expected observations to confirm the presence of the carbonyl functional group in Y. So for a carbonyl functional group, what test we would do, right? I think everyone remember for a carbonyl, they didn't specify, yeah, 2,4-D NPH test, very good. 2,4-D NPH test. Yes. Hassan, Ishal, Banin, very good. Instead, right, add 2,4-D NPH. And orange precipitates observed. Okay. Now, the infrared spectrum of 2-methyl-butanene is shown. Okay. Predict two main differences that would be, okay, good one. Predict two main differences that would be seen between the spectra of Y, that is this one, and of 2-methyl-butanene. Give reasons for your predictions. Your answer should refer only to the region spectrum of over 1500 centimeter inverse. Okay, this is of butene, right? 2-methyl-butanene, it means this one. And if I show, it's this one. Okay, so we have to take or find out the two differences between these two. And for that, we need to look at the chart, the infrared values table, which is over here. So see, there is a C double bond O in Y, and there is no C double bond O in 2-methyl-butanene. So due to this, this peak of carbonyl is shown in Y only. Why it's again stuck? Yes. So this carbonyl C double bond O peak has been shown in Y, but not in 2-methyl-butanene. And further, uh, there is a C double bond O C peak between 1500 to 1680. That has been shown, that has not been present in Y. That is in Y, and that is not in Y. Is this understandable? And there is one more thing that we have studied over there. If you guys recall, let me show you. See, we have studied this thing. There is a carbon-carbon double bond and a carbon bonded to hydrogen. We are getting this peak above 33,000. So this peak would be observed in this compound, but not in Y. Because in Y there is a no carbon-carbon double bond. So first I will write in Y no signal at 3100 centimeter inverse due to C bonded to a hydrogen and dead C has a double bond. It's again stuck. The question was asking, you have a two compounds, one is Y and one is 2-methyl-butyronine. You have to differentiate between their infrared spectra. What the difference you will find in both of them. So in Y, there would be no signal at 3100 centimeter inverse due to this bond, the carbon-hydrogen bond at that carbon has a double bond. Yes, Hadi, did you understand what the question is asking? Then in a carbon double bond oxygen signal or peak at 1670 to 1740. 1670 to 1740 centimeter inverse. And no peak of C double bond C in Y, which is this one, 1500 to 1680. At 1500 to 1680 centimeter inverse. Is this clear? If anyone has any confusion, please ask. So we have to differentiate the spectrum. Here we have a carbon-carbon double bond in this structure. So we are getting the signal of this carbon-carbon double bond over here, but not over here. In Y, we are getting a carbon double bond O signal, which is not over there. Okay. Propanoic acid is reduced by LiLH4. Write an equation to show the reaction. Use hydrogen to represent an atom of hydrogen. Okay. So see, it would be written like this. CH3. Okay. On reducing a carboxylic acid, what product we will get? Yes, we will get a alcohol, a primary alcohol, right? So CH3, CH2, and then the next carbon which has a double bond O also gets CH2OH. And the oxygen which comes out from there forms water. So two hydrogens come here and two hydrogens come here. So we need 4 water. So we put a 4 over here. The equation is balanced. And the oxygen comes out from the carboxylic acid forms water. Name organic product formed in this reaction. So it's a propane 1-ol, right? 3 carbon molecule. Propane 1-ol. Okay. Now, organic compound W is an ester, which is the structural isomer of propanoic acid. State the molecular formula of W. Okay. It's a propanoic acid, right? So see, it's very easy. If you recall the general formula of ester and carboxylic acid, it's like this, CnH2 and O2, isn't it? It's again stuck. Yeah, CnH2 and O2. So it's a propanoic acid, means 3 carbon atoms. So I just put 3 in the general formula. So I'll get the molecular formula. So it would be C3H6O2. So that is the molecular formula for the carboxylic acid as well as ester of 3 carbon atom. Draw possible structure of a W. And W is what? It's an ester, right? And how many carbons ester? 3 carbon ester. So what you will do? Put this C double bond O. Then O Then I would put a C over here. Now it becomes ester. Now it's up to me whether I kept the third carbon over there or over here. Both are considered as correct. If you do this, then put H over here, 2 hydrogens and 3 hydrogens. See, they haven't asked you to write the skeletal formula, the structural formula, right? They have just asked you to write the structure. So if the structural formula has been asked, or so if it's a structure, so you can write it in any way, but if they specify you to write the structural formula, so see, if I did this, then the structural formula would be HCO2, CH2, CH3. And the other possibility, the other possible structure of a W would be like this, as I have told you, double bond O, O, and C. Then keep the other next C over here on the right. It's again stuck. Yeah, see. So 3 carbons over, 3 hydrogens over here and 3 hydrogens over here. So its a structural formula would be like this, CH3, CO2, CH3. So these are the two possibilities which we can draw. Okay. So here the chapter is completed. The paper is completed. Now, if you see the last two questions, each of 12 marks. So out of 60, you got 24 marks from organic. See, this question number 5 is of 12 marks, which comes from the whole organic, and question number 6 is of whole organic. So 24 marks out of 60 marks. And in the same way, when you look for paper 1, almost 12 to 15 MCQs were from organic. Okay. So now I think this will be our last class before Eid. Now we will be continuing after the Eid holidays. Okay. So take care, everyone. See you, inshallah. Yes, I will send the salt pass paper in the group. Okay, then take care, everyone. Allah Hafiz.